I appreciate you stopping by to check out this episode of Vintage Audio Review. And before I get into the review portion, I have a little announcement, and that is on October 19th at 1 p.m. That's a Saturday. I am going to have a live stream. It will be at least a half hour long. If there's a lot of participation, I might stretch it out to an hour. And so that will be a Saturday afternoon, 1 p.m. Mountain Standard Time. But wait, we're going to have a giveaway. And the item that will be given away is a Neo Hypo ET30. That's that dual amplifier speaker switcher that I reviewed in episode 127. You can check out that episode to find more about that. But it's about a $150 piece of equipment. And Neo Hypo has offered that to me to give as a door prize, I guess. You'll have to watch the video, of course, and at some point during the video, probably towards the end, I will tell you how to win that, or live stream. And I'll tell you what you can do to win that ET30. So my hats are off to Neo Hypo. They've been very good working with me. They don't pay me anything. It's just, you know, they have some things every now and then that they would like me to review, and they seem to be a good company to deal with that I've worked with so far. So thanks to Neo Hypo. They do have a Facebook page as well and an Amazon store, I guess you would call it, but look for that on the 19th of October. Okay, in 1984, if you had $530 or about $1,500 today, you could have purchased this LUXMAN L-430 Integrated amplifier. It was rated at 105 watts per channel into 8 ohm loads, both channels driven, at not more than 0.015% THD, and it weighs in at about 30 pounds. The frequency response was listed at plus or minus 1 dB from 10 Hertz to 100 kilohertz. As always, we'll do a tour of the front and the back. I'll pop the cover off. You can see what it looks like inside there. And then, of course, there would be data, and I'll tell you what I thought after using and listening to the L430. Now, the reason I got this is because my good buddy Richard, who has made cameos in several of my videos, had lent this out to one of his lady friends, and at some point he lost a channel, or she lost a channel on it. So he brought it over to me, and I checked it out, and sure enough, I don't know which channel it was. One of them was about 20-30 dB lower than the other channel. So I started pushing in switches, moving dials, that kind of thing, and I found out it was sensitive to the tone direct switch, which switches in the tone controls. In this case, the tone controls are in the amplifier section, which is really unusual because normally they're in the preamp section, but they were in the amplifier section. And I found out that if I pushed it in or out a few times, it seemed to work, but it wasn't reliably holding. Now, a good hint when you have a piece of gear you haven't used in a while, just push in all the switches in and out 10 times, move all the controls, 10 times, just to kind of loosen things up before you even plug it in. I didn't do that with this, but because it needed to be hooked up to the meter to verify the problem. I had a way of getting some lubricant inside the switch. It's a sealed switch, so on some of these you have to be careful. You heat up a really sharp, I have a pointed, like a dental pick, get it red hot and gently poke it in kind of at the top of this switch, and you'll see a picture of it in a little bit. Enough that I could get some lubricant in there, and I squirted some of my cleaner lube stuff and worked it, and that seemed to be fine. So anyway, that was kind of the main thing that was wrong with it. The interesting thing was when I was looking at it, and I separated the preamp section from the power amp section, which is just done by a switch in the back, and I measured just the preamp section and the power amp section. They both look really good by themselves. However, when you mate them together as you normally would use this, and you'll see in the frequency response, it has some issues with the frequency response, and that kind of bothered me. So I did basically testing, most of the testing either as an amp or a preamp. I did put the two together for some measurements, and you'll see that, and it's certainly usable. I don't know what exactly is going on with that impedance mismatch between the two, I'm going to call it, because I actually soldered in little jumper wires between the two channels where the switch is on the back. So basically there was a direct connection and you weren't going through the switch or any of that stuff, and it still looked the same. So I'm not sure what the mismatch is going on between the preamp and the power amp internally. However, when you test them by themselves, they look great. So I'm just kind of throwing that in. And so what we'll do is we'll do the tour and then get into the data, and I'll tell you what I thought. Here's a close-up view of the LUXMAN L-430. Starting on the left, we have our power on-off switch, and when the power is turned on, we have a warm-up indicator here. It goes off after things are stabilized, probably 10 to 15 minutes is what I noticed. We have our bass control here, treble control here. Those are only in effect when you have the tone direct switch out. When it's pressed on, it bypasses the tone controls, which are in the power amplifier section. And when the tone direct is switched on, we have indicator here. We also have indicators for the tape monitor circuit, which are these guys all here, and there's an LED when it's in the recording position. We also have a phono straight indicator right there. We also have a subsonic filter here and a high cut filter right there. Here's our input selector, tuner input, auxiliary input, moving magnet phono input, and then the moving coil phono input. And we do have a high and low impedance switch for the moving coil position, as well as a phono straight position. We have a balance control here, and we do have our big volume control here. There's a mono selector and a low boost selector. Coming around to the back, on the right hand side, we have two switched outlets and one unswitched outlet. These speaker connectors here are not banana jack friendly. You can use a spade lug or a wire to connect to your speakers. Here is our signal processing switch, and when it's in the off position, the power amp and the preamp are connected together, and when you put it to the on position, you can put in a separate input to the power amp here or take your preamp output there. Tape monitor circuits are here. We have some gold-plated phono inputs, as well as our tuner input, and our DAD auxiliary input is here. The phono grounding lug is here, although it's missing the nut that would hold down the wire or spade lug. Here's what the inside of the L430 looks like with the cover removed from the top view. Kind of just shows you how it's configured, and it looks to me that it's fairly easy to get at most of the items should it require repair. And this is a close-up of the tone direct switch. This guy right here, this is a hole that I melted with like a sharp dental pick that I heated up and carefully inserted it in till I was able to make a big enough opening that I could squirt some lubricant in to help with the switch, which was a problem. Here's our standard THD SNR plot at 1 kilohertz with the amplifier section only being driven into 8 ohm loads. The output is about 5 watts into those 8 ohm loads, and the SNR is supposed to be 110 dB for the auxiliary input, which is the one I'm using. And we are a bit shy of that, about 20 dB shy of that, looks like, maybe 23, 24 dB less. However, it's still a decent SNR, and that is with the A weighting applied that the specification was made. So overall, the SNR isn't quite up to the specification, but it still looks fairly decent. Here is just the amplifier section of the L430, and it's being driven at 213.7 millivolts RMS. The THD is much better than the spec of the whole integrated amplifier, which is 0.015% THD with both channels driven into 8 ohm loads. Our SNRs are right around 84, 85 dB. We're putting out 105 watts for the left channel, 108 watts for the right channel. THD plus noise is right around minus 80, 81 dB. And we have a 214 millivolt signal going into the input at 1 kilohertz for this particular test. So the amplifier section is looking pretty good and definitely meeting its specification. Here we are looking at how much power we can get out of the unit with it putting out about 1% THD. It's actually a bit more than that for each channel, and we're around 114, 116 watts. So it's probably good for about maybe 110 watts before the THD gets over 1%. This is into 8 ohm loads, and once again it is just the amplifier section. Right now we're looking at the frequency response of the amplifier section only, with the input level adjusted so that we're putting out about 5 watts into 8 ohm loads. You can see that our frequency response is pretty much within 1/10 of a dB from 20 hertz to 20 kilohertz. The channels are balanced to within I'll say 0.15 dB. So overall, the frequency response looks pretty darn good. Here is a plot showing the L-430's output impedance. In this case, I'm driving just the amplifier alone. And there is no specification for damping factor, but this would translate to a damping factor of 31 for the left channel and 35 for the right channel if I use the values at around 1 kilohertz. Right now I'm looking at the input sensitivity of the L-430. I've got a 200 millivolt signal going into the auxiliary input. With the 200 millivolt signal, you're supposed to get the full 105 watt output, and we're 10, 12 watts less than that. So we're pretty close to that. Our THD is better than the 0.015%, and the SNRs look pretty good at this point. Here's the L-430's amplifier section only's crosstalk, and that's with the active channel putting out 5 watts into 8 ohms. Frequency is 20 hertz to 20 kilohertz. There is no specification for it, but it does pretty good in that it's above, I don't know, 57, 58 dB at the high end of the band, which is pretty good. Here is the noise of the amplifier section only. Its inputs are terminated into shorts, and we're looking at the frequency range from 20 hertz to 20 kilohertz. The specification I could find on noise is less than 0.5 millivolts, and we're better than that. We're in the microvolt range here. So if you put the decimal over, we would be less than the 0.5 millivolt. And you can see it's down around minus 92 dB or so. So it's fairly quiet. Here is a plot showing the L-430's THD versus frequency for several different output power levels, and that's into 8 ohm loads. And this is just the amplifier section by itself. The frequency range is 20 hertz to 20 kilohertz. The minus 14 dBV, that's the input level, and that would be the equivalent of about 95 watts. And minus 30 dBV input would give you about 2.5 watts or so. So that's kind of the power range we're looking at. The specification is that the THD should be better than 0.015%, which would be somewhere here or below. So we're looking pretty good throughout most of the band. I would say our worst case THD. So overall, the THD over frequency looks pretty good. Right now we're looking at our standard THD SNR plot at 1 kilohertz with a 2 volt RMS signal going into the auxiliary input, and I'm measuring at the preamplifier output. You can see there is 0 dB gain. I should point out that the volume control is set for the maximum, so this preamp will not give you any gain. All that is done by the amplifier, but at maximum volume you're seeing about 0 dB gain. THD looks really, really good. SNR looks really, really good, over 100 dB. THD plus noise also looks pretty good. Now there is sort of a specification for the signal to noise ratio with the A weighting on. Let me turn that on. And it says it should be like 110 dB, and we're pretty close to that. It's not really specifying whether that is just the preamp section or the whole unit, but the amplifier definitely wasn't anywhere near 110 dB. But the preamp section alone going through the auxiliary input is 110 dB, so we'll give it credit there. I should mention that we are bypassing the tone control, so the tone direct switch is on for this measurement. Here is the frequency response of just the preamplifier section. So we've got a 0 dBV signal going into the DAD/auxiliary input. We're sweeping from 10 hertz to 50 kilohertz. The volume control is set for a maximum, which is 0 dB gain in this case, and the tone direct switch is on. So we're bypassing the tone controls. The response is really, really flat. At 50 kilohertz, we're only down, 0.25 dB or so. And the channels are balanced, less than 0.1 dB. So overall, this thing has an outstanding frequency response of just the preamplifier section. Right now, I've terminated the auxiliary inputs and I've selected the auxiliary inputs, and we're looking at the system noise level. And this is with the gain set for maximum, which is 0 dB gain, and we're measuring at the preamplifier output. And it looks really good. We're better than 115 dBV down. Right now, we're going to look at the input to input isolation. In this case, our input is the tuner input, which is selected, and our output is the preamplifier output. Volume control is set for 0 dB of gain, maximum volume, and we've got a 0 dBV signal going in, and that's this line right here. Frequency range is 20 hertz to 20 kilohertz, and what I'm going to do is switch over to the auxiliary DAD input, and what we see is the leakage from the tuner input over to that input. The lower the number, or the more negative the number, the better the isolation is. And it looks like we have some power supply noise here at 120 hertz, and probably over here at 360 hertz, I guess. And other than that, it looks better than, the worst case isolation would be about 75 dB from the power supply. But beyond that, the channels look pretty good. Minus 80 dB of isolation down to minus 120 dB of isolation. So overall, I would say the isolation, at least between the tuner input and the auxiliary input, looks pretty good. Right now, we're looking at the frequency response from 10 hertz to 50 kilohertz with a 0 dBV signal applied to the auxiliary input, and we're measuring at the preamplifier output. The volume control is set to give 0 dB gain, which means it's at its maximum. And this line right here is our reference line, so everything is flat. Actually, the tone direct is switched in, so it means we're not going through the tone controls, the bass and treble controls. So what I'm going to do is switch in the high cut filter, which is supposedly at 7 kilohertz, and we'll see what happens with that. Okay, our 7 kilohertz high cut filter is switched on, and 7 kilohertz would be somewhere around here, and we're only down half a dB maybe, and we also seem to have some noise on the right channel. Probably means that switch is in need of some cleaning, but it doesn't really start adding a lot till we're out to maybe 20 kilohertz or so, but the 7 kilohertz isn't buying us a lot when we switch it in. I've now switched in the 30 hertz low cut filter, and that looks like it's doing a little bit more. 30 hertz would be right in here, and it looks like we're down about 7.5 dB. Right now we are looking at the frequency response from 20 hertz to 20 kilohertz of the amplifier section only. And what I am going to do is turn the tone control bypass off, so it will go through the tone controls, which are set at flat, so it has a bass and treble control. And let's see what happens when we do that. Ideally, you would want it to stay in the same position, but usually it varies a little bit. Okay, so I have the tone bypass off, so it's going through the bass and treble controls, which are flat. It looks pretty good, except the bass is down 2 dB, so I'm going to tweak that just a little bit, give it a little bit more bass, and see if I can flatten it out a tad. All right, I've adjusted it to about the 18 position. It's not quite at the 20 on the dial, so we'll call it about 18, and it's pretty flat. What's interesting is that if I adjust the treble control, it seems to affect the bass area more than the treble control, so there's something going on there maybe, but overall it's within 6/7 of a dB worst case. So it looks pretty good right now with the bass control adjusted anyway to give a pretty flat frequency response. Here's our standard THD SNR plot at 1 kilohertz with a 5 millivolt signal going to the phono input, and I've got the selector set so that the moving magnet gain stage is being used, and we're measuring at the preamplifier output with the volume control set for a maximum or 0 dB gain. However, for the phono stage you can see we're almost 37 dB of gain. SNR is not so great, around 40 dB, and the THD looks pretty good at better than 0.002%. I'm going to go ahead and flip on the RIA weighting, and that should improve the SNRs. It did 58 dB, 55 dB, so it does make a difference if you flip in the RIAA weighting. Here is the frequency response of the phono stage with the moving magnet gain position selected. We're measuring at the preamplifier output with the volume control set for a maximum gain. And you can see that it's fairly flat. We got some noise going on here, but it's within plus or minus 0.8 of a dB, which is really good from a phono stage. And of course, we're going from 20 hertz to 20 kilohertz. So overall, the phono stage frequency response looks pretty good. Here's our standard THD SNR plot at 1 kilohertz with the preamp connected to the power amp. I've adjusted the volume control such that we have about 25 dB of gain. The power output is about 5 watts into 8 ohm loads. SNRs look not bad, about 84 dB. THD not bad, better than, we'll say 0.08%. The specification is that it should be better than 0.015%, but I'm not going to really worry about that here. Now, the reason for the you can see it here in the THD plus noise is better on the right channel. Let me get rid of the left channel, and you can see how low these harmonics are on the right channel. So that's the cause. I don't know internally what's causing the left channel to do that. And in case you're wondering a little bit more about the harmonics, let me bring that up. And you can see our even harmonics are higher than the odd harmonics. There's a big difference between the left and right, kind of just what we saw, but the even harmonics are higher than the odd harmonics, at least at 5 watts into 8 ohms. Here is the frequency response from 20 hertz to 20 kilohertz with the L-430's power amplifier and preamplifier sections connected. Now it's putting out 5 watts into 8 ohms, and this looks really strange. When you saw the frequency response of either the power amp or the preamplifier section, they were really flat, and now for whatever reason there's some interaction when the two are combined, and this is what I'm getting. So I'm going to try 1 or 2 more things and then go from there, but right now frequency response does not look really good for either channel. Here we have the frequency response from 20 hertz to 20 kilohertz of both the preamp and the power amp connected together as you would normally use it. It's putting out about 5 watts into 8 ohm loads, and the tone direct switch is on, so we're bypassing the tone controls. The frequency response is baffling to me because I've done a lot of things and I can't get it flatter than this. When you look at just the preamp, it looks great. You look at just the power amp, it looks great. You put the two together, and the right channel's not so bad. It's only down maybe, what, 0.8, 0.7 of a dB here at 20 kilohertz, but the left channel goes anywhere from a plus, 0.8 of a dB down to a minus almost 2 dB here at 20 kilohertz. So I really can't figure this out. I've tried soldering jumpers, bypassing the switch that selects it as a combined integrated amp or to separate the preamp power amp out. So I've actually bypassed that directly with little jumpers that I soldered in, and it made no difference. So I'm not sure what the interaction is between the two, but this is the way that it will stay. Right now we're looking at the frequency response from 20 hertz to 20 kilohertz, And this is with a 0 dBV signal or 1 volt RMS signal applied to the auxiliary input. The L430 is connected as a normal integrated amplifier. In other words, the preamp and power amp sections are tied together. And I just wanted to demonstrate what happens when I switch in the low boost filter. You can see at 20 hertz here, we're at about minus 2 dB. And I'm going to go ahead and switch it in and we'll see where it goes. Okay, so it looks like at 20 hertz it went from minus 2 to plus 7, or about a 9 dB boost at 20 hertz. And that kind of just gives you an idea of what the low boost filter does. I do have a little correction to make, and that is the price of this thing in today's dollars. It's not $1,500, but $1,600, and that would be in September 2024 dollars. As far as how it performed great as far as a preamp. It performed great as far as a power amp, with the caveat that the preamp section's phono stage, there was just some noise getting in there that really detracted from the SNR, but you know, its frequency response wasn't bad as a moving magnet phono preamplifier. The preamp is not going to give you any gain. It's maybe, you know, at max volume it's 0 dB gain, and that's probably because the power amp has over 40 dB gain. So, you know, they both test fine by themselves. When you combine the two, I think it was the, I don't remember which channel now. I start testing so many things and I kind of get a little bit mixed up if it was the right or left channel. But one of them, as an integrated amp, had some issue once you hit about 90 watts. The distortion was, I don't know, 0.2, 0.3, 0.4%. And then as you got up to close to 100 watts where its rating is, it was over 1% for the one channel. The other channel looked fine. So there's some interaction going on when you combine the two. It's beyond the kind of thing that I want to investigate. I have no idea why it works great with my analyzer, but it does. And that being said, the ultimate key would be to listen to it. And probably the way this is going to be used, it's not going to be in a critical situation. So the fact that the frequency response on one channel is not where you would want it isn't going to be a factor in whoever is going to get it. Even if Richard uses it, nobody's going to really notice that for the most part. I hooked it up to the Wilson Watt 3 Puppy 2 loudspeakers and just terminated the auxiliary inputs into shorts. After this thing warmed up, it had very little hiss, just a very high level hiss. It was, you know, very, very low. I had to strain to hear it. So it's fairly quiet. And that was with the volume control set for probably maximum gain. So there was very little noise out of this guy at that point. When I listened to music for a while, the standard music, I thought it sounded just fine. I thought it actually sounded good. Now, I did like that low boost switched on for some of the tracks to get that extra bass out of there that I really enjoy, but I didn't have it on for all the tracks that I listened to, and it sounded really good. I was surprised. I just thought it did a good job despite that frequency response, which was probably worse at the low frequency part of the band, and you know, it's not as directional there, the sound. And you know, for the most part, I just thought it did a good job. So, you know, it's going to be a mystery, I think, as to why there is that little problem, but you know, it worked well, in my opinion. So it's got a lot of versatility as far as inputs and that kind of stuff, and I just think it has kind of a nice look. So if you're running across one of these things for a reasonable price, I'm not sure what that would be for you, but you know, it would not be a bad amplifier. It had plenty of oomph. I was able to get SPLs, probably 92 dB, which is about as loud as I would need something to get. And you know, for the most part, I would, you know, say it's an okay integrated amplifier. So don't forget, once again, on October 19th at 1 p.m. Mountain Standard Time, I will be doing a live stream, and you'll have a chance to win the Neo Hippo ET30 dual amplifier speaker switcher. If you liked the video, please give me a thumbs up. If you have questions and comments, leave them in the appropriate area. I do respond to all of them, or I try to. And if you have not subscribed to the channel, please do so. So until next time, have a great day or night.